Hi everyone, in this video we're going to discuss about gamma distribution. So a random variable or a continuous random variable x is said to have a gamma distribution if its PDF is given by f of x is equal to m raised to p divided by gamma p e raised to minus mx into x raised to p minus 1, where x takes the values greater than 0, that is x takes the values from 0 to infinity, and the m and p are the parameters, and these parameters also takes values greater than 0. I have also given one more function where f of x is equal to beta raised to alpha divided by gamma alpha e raised to minus beta x raised to alpha minus 1, where still the support of x is from 0 to infinity and alpha and beta are the parameters and both takes values greater than 0. So these are the two common notations that we see in gamma distribution. One is when m and p are the parameters, and here it is beta and alpha are the parameters. While discussing about the normal distribution, we have come across a function called gamma function. So that function was integral 0 to infinity e raised to minus mx x raised to p minus 1 dx was equal to gamma p divided by m raised to p. So this was that function which we called the gamma function. So this function we will get from this formal definition or the PDF of gamma distribution. We know for a function f of x to be a PDF, this f of x must be greater than 0, and also this f of x over the full range of x, integrating this f of x over the full range of x dx must be 1. So it is been said that f of x m raised to p divided by gamma p e raised to minus mx x raised to p minus 1 is a PDF. So these two conditions must be satisfied. So we are going to check whether these two are satisfied, and if it is satisfied, will we get this function. So that is what we are going to do. So we are going to check whether f of x is greater than 0. Yes, we know m and p both takes values positive or both takes values greater than 0. Therefore, this quantity is a positive quantity. Now, e raised to minus mx. So any function in its exponents is always greater than 0. And x raised to p minus 1. That is also is a positive value since x is greater than 0. Yes. So f of x is a non-negative function. Now what we are going to check is, we are going to check whether integral over x f of x dx is equal to 1, or what we are going to do is, if this is equal to 1, then we are going to check what is integral 0 to infinity e raised to minus mx x raised to p minus 1 dx. So integral over the range of x f of x dx is equal to integral from 0 to infinity m raised to p divided by gamma p e raised to minus mx x raised to p minus 1 dx. And we know it is equal to 1 since this is a PDF. Now what we are going to do is, we are going to take these constants outside since it does not involve the variable x. So m raised to p divided by gamma p can be taken outside. Integral 0 to infinity e raised to minus mx x raised to p minus 1 dx, which is equal to 1. So from here we will get integral 0 to infinity e raised to minus mx x raised to p minus 1 dx is equal to 1 divided by, I can take these constants to the other side, m raised to p divided by gamma p, which is equal to gamma p divided by m raised to p. So we have got this integral value, integral 0 to infinity e raised to minus mx x raised to p minus 1 dx as gamma p divided by m raised to p. So here we are going to discuss about the mean and the variance of this gamma distribution, keeping the parameters as beta and alpha. So I have used this notation because in standard books what we see is this notation and not the notation that we have followed where m and p. So first of all, we are going to discuss about the mean of gamma distribution using this notations where alpha and beta are the parameters. So the mean is expectation of x, and expectation of x is equal to integral over the range of x f of x dx, which is equal to integral from 0 to infinity, since the range of x is from 0 to infinity, x into beta raised to alpha divided by gamma alpha e raised to minus beta x raised to alpha minus 1 dx. Yes, so I can take the constant terms outside. So it is beta raised to alpha divided by gamma alpha into integral 0 to infinity x e raised to minus beta x raised to alpha minus 1 dx. So this is what is left. So here I have an x and this is also an x term. So I am going to club these both. So this is equal to beta raised to alpha divided by gamma alpha integral 0 to infinity e raised to minus beta x raised to alpha plus 1 minus 1 dx. So this is of the form that we have discussed. So this is equal to beta raised to alpha divided by gamma alpha into gamma alpha plus 1 divided by beta raised to alpha plus 1 from the gamma function. So this can be considered instead of this alpha plus 1. Beta is same as beta itself. So we can write it as gamma alpha plus 1 divided by beta raised to alpha plus 1. So which is equal to, here we do have a beta raised to alpha in the numerator, and in the denominator we have beta raised to alpha plus 1. So in the denominator there is a beta that is left, and we know gamma alpha plus 1 is equal to alpha factorial, and gamma alpha is equal to alpha minus 1 factorial. So I can write gamma alpha plus 1 as alpha factorial and the denominator as alpha minus 1 factorial. So from here I will get it as alpha divided by beta. So this is the mean of the gamma distribution where the parameters are alpha and beta. Now we are going to consider the variance of gamma distribution. So to find the variance of gamma distribution, variance of x is equal to expectation of x, the x square minus expectation of x the whole square. So we know expectation of x. So we can find expectation of x the whole square using this mean. And what we require is to find the expectation of x square. So expectation of x square is equal to integral over the range of x square into f of x dx. So which is equal to integral 0 to infinity x square into beta raised to alpha divided by gamma alpha e raised to minus beta x, x raised to alpha minus 1 dx. So from here, as always, I am going to take this constants outside the integral function. Integral 0 to infinity x square e raised to minus beta x, x raised to alpha minus 1 dx. So from here, I am going to club x terms together. So beta raised to alpha divided by gamma alpha into integral 0 to infinity e raised to minus beta x, x raised to alpha plus 2 minus 1 dx. So this is again the gamma function, and we know the value of integral 0 to infinity e raised to this function. So this is equal to beta raised to alpha divided by gamma alpha into gamma alpha plus 2 divided by beta raised to alpha plus 2. Yes, from here we have beta raised to alpha in the numerator and beta raised to alpha plus 2 in the denominator. So what is left is beta square in the denominator, and we have gamma alpha and gamma alpha plus 2. So this is equal to alpha plus 1 factorial divided by alpha minus 1 factorial into beta square. So this is equal to alpha plus 1 into alpha divided by beta square. So this is the value of expectation of x square. Now we require to find the variance of x, where variance of x is equal to expectation of x square minus expectation of x the whole square. So we know expectation of x square is equal to alpha into alpha plus 1 divided by beta square minus expectation of x is equal to alpha by beta and its square. So this is the variance of x, which is equal to alpha into alpha plus 1 minus alpha by beta square. Here also we do have this alpha by beta square. So the denominator is the same, beta square. So we can take beta square to be common. So alpha into alpha plus 1 minus alpha square divided by beta square, which is equal to alpha square plus alpha minus alpha square divided by beta square, and we will get it as alpha divided by beta square. So this is the variance of gamma distribution having parameters as alpha and beta. And expectation of x, the mean is equal to alpha by beta, where the variance is equal to alpha by beta square. So if we were considering the other function or other PDF where the parameters were m and p, then our mean function would have been p by m and the variance would have been p divided by m square. So if it was the alternative PDF that we were using to find the variance and the expectation of x, then it would have been p by m as the mean and p by m square as the variance. But what we have followed is a standard notation where alpha and beta are used. Now we are going to discuss about the moment generating function. The moment generating function, we all know it is expectation of e raised to tx, which is equal to integral over the range of x, e raised to tx into f of x dx. So this is equal to integral 0 to infinity e raised to tx into beta raised to alpha divided by gamma alpha x raised to alpha minus 1 into e raised to minus beta x dx. So from here I am going to take this term, which is a constant term, outside. So beta raised to alpha divided by gamma alpha is taken outside. Integral is from 0 to infinity, and e raised to tx into e raised to minus beta x into x raised to alpha minus 1 dx. So this is equal to beta raised to alpha divided by gamma alpha, integral 0 to infinity. There are two exponential terms, so I am going to club them. So e raised to minus beta minus t into x raised to alpha minus 1 dx. We know this is of the form of the gamma distribution or the gamma function. So from here we will get the value as beta raised to alpha divided by gamma alpha into gamma alpha divided by beta minus t whole power alpha. Since this function has replaced the beta function, the parameter beta has been replaced by beta minus t, and alpha minus 1 is same. So the numerator will have alpha, gamma alpha, and the denominator, instead of this beta, we will have beta minus t raised to alpha. So we will get it as beta by alpha divided by beta minus t raised to alpha, which is equal to beta by beta minus t whole raised to alpha, and from here we will get it as one divided by 1 minus t by beta whole power alpha, which is equal to 1 minus t by beta whole raised to minus alpha. So this is the m.g.f of the gamma distribution.